my job is to answer the question, what have ETSI NFV really been doing all this time? Because you published so many specifications such a long time ago. What have you been up to? And the answer is, we've been taking them to the next level of detail. And one of the great things about ETSI is we go from, it's about this big and it does sort of this, all the way down to machine level. And that's really what we've been investigating in Release 3, is to look at operational aspects. Operational aspects are those things which is the difference between being in a lab and finally getting it to work and being very, very, very happy about this and reporting a success, and deploying a service for multiple million users and making revenue. Operational aspects are those things that make sure that this thing is scalable and caters for all those other aspects of networking. Now, we want to make sure that this is multi-vendor as well, because if we're having a multi-vendor ecosystem to allow you to deploy NFV, we also want to have a multi-vendor system to allow you to manage NFV. And the next thing is to make sure that we don't get left behind, because this is a fast-moving technology space. There's no point in us spending all this energy without a view to the future and how we need to evolve what we're doing to constantly take advantage of new technologies as they become available. This list of operational features is basically what I'll cover today. This is not the full list, this is just the list that we could fit into the time slot available. So let's start with something that I think is a human nature characteristics. We're all used to click and collect, the ability to make sure that when you get there, the thing that you're going for exists. And service providers, if they're working in an environment where they're maybe sharing resources amongst many departments and they want to go and do something big, they want to make sure that the resources are there by the time they've actually deployed it. They also have a wealth of knowledge that tells you that on New Year's Eve, you're going to have a spike of traffic. And so you might want to reserve things with the knowledge that you will need them. You also have to consider that not everything will be on generic hardware. Some things might require, as Alex has pointed out, some very specific hardware security capabilities, for example. So there's a whole list of reasons why you might want to reserve some infrastructure or compute resources. And so because ETSI NFV sits on the infrastructure, or the NFVI infrastructure, we can only use what others make available. And what we've seen is OPNFV take this requirement from the carriers and evolve it and then upstream it into OpenStack, which I believe is now called the Blazia project. And that's now reached the level of maturity where it's now being used in test networks. And I believe the Chameleon Cloud are using this at the moment. And so what we have now is a capability that allows you to define how you want to basically reserve resources from an orchestration perspective. Now, when we started the journey in NFV, we wanted to make sure that we had a very solid foundation. And one of the early agreements was that we wouldn't have policy in Release 2. The reason being is that you can, if something's complicated, you can just draw a line and says that's handled by policy. And what we wanted to make sure is we had a solid foundation that didn't do that. But now we've got that solid foundation. It's time to draw a line and say we can do that with policy. And so what we have is an analysis of the types of policies that you would like to use at different reference points within the system. And that specification was published last year as IFA 23 and is available. You'll notice that as we go through this presentation, at the bottom corner, there are specification references. These are all clickable links. So if you download the presentation, you'll be able to go directly to the specifications. So what we have is we want to make sure that now we've got this foundation, we've got the flexibility to allow policy across all the reference points and be able to sort of add a policy, delete a policy, query a policy. And so we're now into the realm of saying, well, if you want to have special behavior for your VNF in this scenario, we can create a policy that will basically allow you to describe that behavior. Now, my experience of policy from other domains is that policy tends to be one of those subjects where you, first of all, create a framework, and then you spend a lot of energy trying to get into working to work. So it tends to be one of those things that tends to evolve release after release. The next thing is taking snapshots. Virtual machines are great because you can take a snapshot and then you can basically reinstantiate the virtual machine with that snapshot. But a VNF is not just one VM. A VNF may be multiple VMs. So now, if I'm a service provider and I've got this VNF working really well, and I want to take an image of what it looks like on a good day, I want to be able to have a way of structuring all the VMs, all the images, and be able to retrieve that. VM images might be substantial in size. So what we're not saying that we create the biggest file in the world. What we're saying is that there's going to be a storage process for storing VM images. But what we need to do is to build something that will allow the orchestrator to go and obtain via reference where these images are stored. And so what we've done is there's been a thorough analysis of the issues around this, and that's now published in TST 005. And we are working towards defining on the various reference points the information model to allow us to have this process of obtaining or of requesting a snapshot, building the package, providing references, and retrieving information. So it's the classic example of when I have a watcher that watches something, who watches the watcher? We have a situation where we've said, all this VNF magic going on over here, we need a system to manage it. So we'll have VNF managers, we'll have orchestrators, and we'll make it multi-vendor. Well, that means that you'll probably in your network have VNF managers from more than one vendor. You need to have some sort of a system that says, well, actually, when a new VNF manager comes online, how do I know? When a VNF manager falls over, what can I do about it? So we need to have an ecosystem that basically looks after the MANO layer. So it takes into consideration all the real-world challenges that you will have running a virtualized environment. So what we did was a very detailed study in IFA 21, which was published just recently, at the start of the year. And that goes into great detail of the types of scenarios that you might encounter and the type of capabilities that you might desire from a perspective of looking after the MANO itself, the VNF managers. How does a VNF manager find the orchestrator? I mean, there's lots of simple challenges there that need answers. And so we're currently developing specifications to realize this, and that specification will be in IFA 31. We finally managed to get a sort of a scheme of numbering where the number in the 20 series maps to the number in the 30 series. However, that doesn't happen for every occurrence. So apologies. Okay, don't even attempt to read the words on the diagram. This was grabbed from the specification IFA 22, which was, I think, published last week. And what we're doing here is one of the things about virtualization is you have to take information modeling down to reality. So I can draw a nice line, and this nice line at the top says, this is a VNF. This is a VNF. They're in different data centers. Okay, so we'll just draw a line between the two and call that a virtual link. Great. Well, okay, what creates that virtual link? Well, the answer is many pieces of equipment. And you have to talk to those many pieces of equipment to establish the underlying foundation that eventually gives you that virtual link. And so what we've investigated is the idea that, as has been pointed out a number of times already, you're going to be dealing at national level with multiple data centers, and your services are going to span your countries. So therefore, you need to be able to cater for the fact that you're going to deal with WANs. You're going to have to connect this town to that town to make sure this service works. And that's really the focus of this initiative. Again, we have a specification because it's quite a complicated area that's looking at defining the architecture and information model for this. Okay. The most important thing typically is money. Well, regulation as well. When you enter a software business, you are in the business to make money as a software vendor. As a user, you're in the business not to go bankrupt by using too many software licenses, because at the end of the day, software has to be paid for. If you don't fit into either of those categories, you're probably doing something corrupt, which means that there's a trust issue here. And when we're dealing with software, how do we trust that the right thing is happening? Particularly when we're dealing with an environment which is under the control of, for example, a service provider. So we've got a number of challenging issues here. How do I onboard a license? It's not, I mean, for example, in the old days, if you wanted to have multiple licenses, you actually physically went out and got multiple disks. And then someone said, well, you really just need one disk, and then you can have a range of licenses. And so the idea here is that you don't want to tightly couple your onboarding with your licensing. You want to have some flexibility there. However, you do need to couple the usage with licensing, because if you release your VNF package out into the wild and somebody finds a way of deploying it without any license, well, you've just given away a lot of value. And that's not something that vendors want to be doing. So where is this management taking place? Well, the answer is the license manager doesn't exist in the MANO itself. It exists in the OSS layer. So we're not touching that. We've just got a concept of what it does, and it lives above where ETSI NFV has to define. But it does have to interact with MANO. We do have to know how things are getting used, when things should and should not be used. And we have to have this trust, because if it can be abused, then the industry won't use it. So this is quite an active topic, as you can imagine. It's quite foundational to the whole deployment of VNFs. Going back to the issue of different business models. Now, we've seen in the mobile sector, for example, that you could be a virtual mobile network operator. You don't need to own the infrastructure or all the infrastructure to be able to provide a service. Well, why do I need to own the data center to be able to deploy a VNF or a network service? In fact, why do I need to own every aspect of my network service? And so there's a number of questions there that says that to have a flexible business model, you should be able to do pretty much whatever you like. Now, the challenge is, how do you coordinate that? How do you make sure that I am going to use your resources, or I'm going to use your network service? Well, you need to have some dialogue between the various controlling entities. So what we're looking at the moment is actually creating an interface between NFVOs. And this is going to use a lot of the functionality that we've described during the network service presentation in IFA 13. So again, we've deployed VNFs now. It's all running. We've addressed the operational challenges we've mentioned. We've got everything nicely licensed. And then within a matter of weeks, somebody tells you it needs patched, or the infrastructure needs patched, or the actual MANO needs patched. So we might as well start from the perspective of thinking that everything needs patched on a fairly regular basis, and then that's before you get into actual upgrading. So we distinguish the two processes of update, which is bug fixing, and upgrade, where you're actually providing new functionality. Now, what you want to achieve is you want to achieve continuation of service. Now, how do you achieve that? It's that classic example of how do I fix the plane while flying in it? Well, it's much healthier to actually get off the plane, get on another plane, and take some sensible measures. Now, there are situations where you can do certain level of maintenance mid-air, and you need to understand the difference. And so, again, what we need is coherent processes, and what we have is a very good specification that describes the requirements in REL 006. And then we need to have some interaction between the MANO layer and the underlying NFVI, and how, for example, the vendor of the VNF would provide guidance on providing software updating and upgrading. So there's a whole lot of issues here that are being worked on in terms of we have to be able to upgrade and update the software, but making sure that's done in a coherent fashion. Okay, I'm going to move on now to the how do we make sure that we don't become irrelevant. Network slicing is a hot topic. It's coming from the 5G domain. The idea that you can have a network with the characteristics that is suitable for your service. Now, from the macro level, we can create the service that you want by you requesting through the service description the service that you desire. And the idea is that the ETSI NFV isn't going to run network slicing. ETSI NFV is going to provide network slicing. So the actual management of network slicing lives in the OSS domain. But there have been a few issues identified, and a lot of them relate to the topics we've already discussed in the operational side of things. When you're talking about multi-domains, in terms of multiple physical locations, or party A buys part of a service from party B, how does that relate to realizing network slicing? In the 5G domain, there's a concept that your network slicing might occur very rapidly. So this isn't going to be a question of we spent a couple of weeks planning this and now we're going to deploy it. The actual rate of network service deployment might be very high. So we now need to talk about load to make sure that the actual MANO can handle the load involved in high volume network service deployment. Security, I think Alex has pretty much covered all those aspects. You have to care about what it is you're deploying on, where is the thing that you're deploying on. So there's many considerations there. And then priority. So priority is one of those things that's very, very easy to explain and very hard to do, because it's clear that, for example, that in the case of emergency, you take these actions and the online gaming service, for example, might get a lower priority than the emergency response services, and you can very clearly create a vision of what the appropriate action is there. But what happens in that sort of gray zone between, it's not a critical emergency type prioritization, but what does priority actually mean in terms of the ability to deploy, to preempt, and so forth? So that's quite a complicated issue that's being considered. So as we move from virtual machines that we all know and love and contemplate the idea of moving into containers, then we might also want to think about how we tackle the approach to decomposition of services. Now, certainly within the 5G domain, they're looking at far greater level of decomposition of services. And so this whole idea of cloud native, of making everything a little service and then being able to scale it and use it. This is an area that we've been looking at for a while. There's a couple of references here. That's EVE 11 and IFA 29. EVE 11 looks at the characteristics for what we considered as a cloud-native VNF. And IFA 29 looks at the issue of, well, what do we need to change? What do we need to change if we start looking at things like platform as a service? And what does cloud-native mean to the existing MANO architecture? So this is still ongoing work. And then edge. So Don covered this morning the issue of where you do things has advantages and disadvantages. Are you in the core competing with the billions, or are you at the edge where things are maybe more expensive to deploy? Edge computing is coming. And from an NFV perspective, there's certainly merit in the idea that why can't you deploy the MEC environment using NFV? And so we have this concept of MEC in NFV. Now that's not, I mean, it can be quite confusing to conflate these two issues, because the idea is to make sure that you have something that's fairly seamless in terms of which entities are doing what tasks. So this isn't NFV becomes MEC, this is you deploy MEC through NFV. And then certain tasks are taken on by the VNFM and the NFVO. Now, the MEC working group in ETSI is a separate working group, or ISG, sorry. And so what we've done is we've set up a framework for collaboration to take this from the current report, which is in MEC 17, and make sure that any additional capabilities that are required to realize that are developed over the coming year. So the next question is, okay, this sounds all very exciting, but when can I have it? And the answer is that we are working on a process of, we've done the reports. The reports have been linked in this presentation. Now we need to do the information model. We need to do the detailed specifications. And the features here, as you can see, they are not the big sort of next generation cloud native type scale big thought features. They are some of the more clearly defined features where we are able to, in the next couple of weeks, complete the standardization. And the idea is that we will hopefully have this published in August this year for these 4 features. So we have this idea of publishing every 6 months. So every 6 months, we publish a maintenance release. We gather in all the input from all the changes that we've had provided to us, and we create an update. Now, because we are modifying the core specifications to develop these or deploy these features, then we're in a situation where we want to synchronize that release of features with the release of the other specifications. So the message is really every 6 months you should get another batch of features from that list and more. So you should get a batch of features in August this year, and then another batch in February next year. Then we basically pass it over to Thin and the Sol group, who will develop the APIs and data model specifications. So the key message here is that we have a pipeline of features. That's what we've been up to. We have been, over the last year and a bit, developing the analysis, which is going to be the foundation of the detailed specification work. And that's good because, as you've seen on some of the slides today, we are working at a very, very detailed level. And sometimes you need an easier to understand document to allow you to follow the thought path all the way down to the very detailed specifications. And as Joanne pointed out earlier, we're going to be busy for the next 18 months at least doing this. And in true tradition, lots of information. That's it. Any questions? Okay. Thank you very much.
Very